See how y'all are doing. So remember, no amount of verification constitutes a proof. Verification is using actual numbers, case by case thing, if you will, like looking out the window to see if it's raining. And proof is for all values, for all windows. Okay, so it's physically impossible to check all windows, just like it's physically impossible to check all numbers. So the way that we do proof is we use variables, which can then take on any values. But sometimes it's nice to verify, right? Just to see if it works in a certain particular case. So that's what I was having y'all do here. We'll do kind of the same thing. We'll draw a line down the middle here because you don't want to cross-contaminate. And we're going to choose not a random angle, but when I made this worksheet, I just kind of arbitrarily chose pi 6. So when we plug it in, we'll get tangent of pi 6 on this side. And over here we get cotangent of pi halves minus pi 6. Now, if this is an identity, these should be the same. But assuming that maybe we don't even know it's an identity, we're just going to see if it works for this angle. So, kind of going back to those fun unit circle quizzes that we all enjoyed while I was gone. I was sick that I couldn't be here with y'all. And that's why I wasn't here with y'all. I was sick. Like you can't get better until you actually leave the hospital. Have you ever heard that? Take it from me. If you're in the hospital and you're sick, you can't get better until you actually leave the hospital, because the hospital is not a fun place to be. Anyway, what is tangent of pi 6? I'm sorry. Square root of 3 over 3, right? Boom. You got that, right? It's 1/2 over square root of 3 halves, which is 1 over the square root of 3. Then you rationalize it. Good. So over here, what is cotangent of pi halves minus pi 6? It's also square root of 3 over 3. Hey, it works. What? No, that's not how we do that, right? That's where you lose points. That's where you're forcing the issue. You're anticipating what the results are going to be, and you're just putting the results there without providing the work, right? It may not be true. So your dear Aunt Sally would say to work the inside first. So pi halves minus pi 6. Pi halves is how many pi 6? 3 pi 6, right? You multiply by 3 over 3 in your head. So you get 3 pi 6 minus 1 pi 6 is 2 pi 6, which simplifies to 1 pi third. Okay. Now, if you need to show more steps, right? And now what is cotangent of pi thirds? Square root of 3 over 3. So, yes, we'll put a check mark there. We don't get as excited when we verify it. Like, we don't sign off like sizzle or anything. We just put like a check, like, okay. Announcements.
Working after school today in the hall. Things are turning out super cute. You want to be a part of it because it's going to be amazing. Number 2, part of the whole thing is the WAR Act, which is like all about taking care of the environment. So we're kind of tying that into like a nice little touch at the end of the hall is going to be like the junior class pledging to like do their part and whatever. And I have the quote's going to be like something like, "We are the class of 2020. Sorry. We speak for the trees. I have a couple of options up there. So at some point, can the juniors go out and sign this?
Yes.
So my goals have every junior sign it.
Absolutely. We will shut it down a little prematurely today and take a field trip to the hallway.
Perfect.
Yeah.
Field trip.
Field trip. Wait. We don't have permission slips. We'll break the rules. We'll go out in the hallway without that. All right. I hope your parents don't mind. Okay. So square root of 3 equals square root of 3. Square root of 3 over 3 equals square root of 3 over 3. Great. So does that mean that this, because it works for that angle, does it mean that it works for all angles? No. We've checked one window and it's not raining outside of it. Let's check another window. Let's check out the 7 pi fourths window. All right. So tangent of 7 pi fourths. We'll draw the line through the equal, which is kind of like putting a not equal sign there, I guess. And then we got cotangent of pi halves minus 7 pi fourths. Okay, now before we jump in and do that, let's look at what we did over here. If we convert this to, degrees, remember pi halves is 90 degrees and pi 6 is 30 degrees, right? So in geometry, you had complementary angles. They both had to be acute, didn't they? Very acute, because they were interior angles of polygons, okay? So 90 minus 30 degrees gave you 60. Perfect. We're not in geometry. We're on the coordinate plane. So now I have 90 degrees minus 7 freaking pi fourths. What is that? You remember? On the unit circle? You filled it in. It's quadrant 4. The reference angle is pi fourths, or 45. So it's 360 minus 45, which is 315. Holy moly, really? We could do 90 minus 315? Yes, we sure can. What is 90 minus 315? No. 225. Why 220? I was putting the degree symbol too big. Yeah. There you go. 225 negative, right? Negative 225. Negative 225. What the heck? So are you telling me that negative 225 degrees and positive 315 degrees are complementary? Yes, it's exactly what we're saying. Thank you, George. That's what we're saying. So we don't have to limit ourselves anymore to just acute angles, right? Two angles add up to 90. They could be negative, so they could be reflexive angles, they could be huge, all right? So we're not limited by that anymore. Ooh, this desk is sticky. Nasty. Okay, so let's try it now. What is tangent of 7 pi fourths? It's on my finger. What is tangent of 7 pi fourths? Yeah, it is. On my middle finger, this one. It's on this finger. Very good. Tangent of 7 pi fourths is negative 1. What is pi halves minus 7 pi fourths? Pi halves is how many pi fourths? 2 pi fourths. What's 2 pi fourths minus 7 pi fourths? Negative 5 pi fourths. Very good. Very good. Let me catch up with y'all. That's cotangent of negative, what'd you say, 5 pi fourths? Okay, now, there's a couple of options here. Okay, you can either evaluate it at negative 5 pi fourths. We know where that is. Negative means we're rotating what? Clockwise, right. Counterclockwise, if you will. Right? Counterclockwise. And that's going to take us over here, right? Which is coterminal with, right? That's negative 5 pi fourths, yeah? We're going a little bit past 4 pi fourths, which is pi. That is going to be coterminal with 3 pi fourths. So you could either say that this is going to be the same as cotangent of 3 pi fourths. Now notice we're not saying negative 5 pi fourths and 3 pi fourths are equal, but because they're coterminal, they have the same trig value. So cotangent of that one's equal to cotangent of that one. Or we can use symmetry. Cotangent is even, odd, or neither. It's odd, right? Like, how did this sticky stuff get on here? That's rather odd. And, ooh, okay. So for odd functions, negative inputs, what? Become negative outputs, or do we just forget about them? Negative outputs, right? So we can also write that as negative cotangent of positive 5 pi fourths. Either one would work, right? It's up to you. So let's go ahead and evaluate both of them. I got negative right here. What is cotangent of positive 5 pi fourths? Positive 5 pi fourths would be over here. What's cotangent of positive 5 pi fourths? 1. So we end up with negative times 1, which is negative, which that works on the left side, so check. Or we could have chosen just to do cotangent of 3 pi fourths, which 3 pi fourths is over here, where that's also negative 1. So look at this. We got negative 1 equals negative 1 equals negative 1. I feel like saying that again, negative 1. I mean, wow. Just walk around all day saying that. Negative 1 equals negative 1. equals -1, everybody. And then you'll lose friends fast. Okay. Yeah, so I'm going to put in an order for these desks to be wiped down daily. I don't think that's happening. Yeah, but not with like, you know.
They just grab their towel and just kind of.
Right, and you know what also is the custodian that worked up here in this hallway quit at the beginning of the week, so they're really shorthanded.
Wait at the beginning of the week.
Yeah, like called in Monday and said, I'm not working here anymore. And then everyone else has to pick up the slack. So that's not being a very good teammate, you know. Okay, so anyway, with no indication, it's kind of like Magic Johnson stepping down from the Lakers, just like boom, out of the blue, I'm gone. What? Okay, if you don't follow sports. Sports, right? Some people go sports ball, right? But not all sports are ball, right? I mean, track, chess, right? Math, bowling. Sure. Mm-hmm. Leading cheers is definitely a sport. Rallying pep is a sport. What?
Yeah, you box for like a minute and a half, and then you play chess for like a minute and a half, and then you box.
And the first one to get dementia and forget the rules loses? All right.
It's the national sport of China. It is the national.
Okay. I'm glad we've. That reminds me of a new dance called the Chinese ping pong player. Right? There you look at that. And you got to do like a one-handed cartwheel, you know. Anyway, let's go to example 5. Example 5. There is something called a counterexample. Okay. Now there are 2 types of counterexamples. If you look back here, here's a horizontal flat surface on which we can put things. This has a really nice laminate on top of a poly substrate, probably MDF fiberboard, medium density fiberboards base. So when someone decided what type of laminate covering, they chose this kind of light brown with some intermittent breakups in there to kind of hide dust and stuff. So this would just be one example of a particular type of counter, right? That's not what we're talking about, though, because that would be counterexample 2 words. This is counterexample 1 word. Okay, so what does counter? No, it didn't go anywhere. It was just a really bad joke. Okay, so counter by itself can mean several things. It could mean like, hey, I put your order on the counter. Why don't you take it? That's, whatever. If you're in a diner, I guess. A flat surface on which you can put orders, right? Kitchen counter, right? Where are my keys? Right there where I left them, on the kitchen counter. Silly me, okay? That's one counter. You can also have like counters, like how many people go through a turnstile. 1 many, 2 many, 3, you're counting. Or how many hits did a baseball player get? Or how many seconds did a runner take to, trip over a hurdle, whatever. To clear a hurdle, and win the race, right? So you can count. But there's also like counter arguments. Have you heard of that? And that doesn't mean like this is the best Formica. No, I like different. I don't like Formica. I like Wilson Art, right? Yeah, that's just my old construction coming back. That's 2 different brands of laminate covering. You got the Formica and then you got Wilson Art. So people arguing like, that would be one type of counterexample. Another type of counter argument would be like, when they're trying to figure out, oh, he finished the race in 5.3 seconds. No, it was 5.4 seconds. No, 5.3. They're arguing over the counting. That's not really what a counter argument is. What does counter mean in counter argument? Against. Very good. Counter means opposing, against. So a counter example, 1 word, is an argument that goes against something, okay? In this case, if you claim something is true for all values, you can disprove that by finding a single counterexample, right? To prove that something's true, you have to show it's true for all values. But to show that something mathematically is not true, all you have to do is find one example that shows it's not true. And that thing can work for all of the values in the whole wide world, but if it doesn't work for just one, we say in mathematics it's not true, okay? So that's what a counterexample is. So we're going to assume that on example 5, we have ourselves some identities. We're going to claim, or someone's going to claim, very shallow-mindedly going to claim, these are identities, right? You walk around saying, it's raining outside of every window, and someone says, hey, did you take a look out this window? No, it's not raining, crap. Okay, there goes that theory, right? We have a theory that the square root of x squared plus y squared equals x plus y. Keep your hand down if you've ever tried that. I know, right? Everybody has at least once in their life, right? Yeah. Oh, that's just, oh, they're perfect. X plus y. No. We kind of went over that at the beginning of the year, that is not true because x squared and y squared are not factors, but what? Terms. Very good, terms. They're terms. So this is not true. Let's prove that it's not true. And again, if you're still kind of inclined to do this, this will prevent you from ever doing it again, all right? So let's choose some values like, I'm just going to arbitrarily choose x equals 0 and y equals 0. Just kind of randomly. All right, so let's go ahead and plug them into both sides. We get the square root of 0 squared plus 0 squared. And on this side, we get 0 plus 0. And now if I simplify, I get the square root of 0. Over here, I get 0. And the square root of 0 is 0. And I get 0 equals 0. And I'm like, see, I told you it was true. I told you it was true. Therefore, it must be true, right? No. We just found a set that works. Let's try a different one. We'll draw a line here. Let's try x equals 0 and y equals 1. You don't want to choose the same number. That's kind of stupid. So let's try two different numbers. The square root of 0 squared plus 1 squared, and over here we get 0 plus 1. All right, this one should disprove it, right? That's going to be square root of 1. Over here we get 1. Square root of 1 is 1, 1. My theory is true. That is true. Spread the word. Do that every time. It works, right? We're 2 for 2. I'm just excited. I've been telling students for 20 years that you can't do that. That doesn't work. And now here I am discovering that it is in fact true, right? It works. Right? Huh? It doesn't? What are you talking about, Willis? Well, haven't we tried them all already? Yeah. Yeah. Let's try two different ones. How about x equals 3 and y equals 4? Let's kind of mix it up a little bit here. On the left side, I'll do it like this. We're going to get 3 squared plus 4 squared. And on this side, we're going to get 3 plus 4. So let's see. Over here, we're going to get the square root of 9 plus 16. That's the square root of 25. And this is 5 on this side. And on the right side, we get 4 plus 3, which is also 5. Yeah! Okay. Yeah. I can work for the government, right? It's not 5? If we start telling enough people that it is, they'll start believing it. If we just to spread the word, nationwide campaign, social media, 3 plus 4 is 5, people will start believing it. They'll start forgetting what the truth is, right? What is the whole thing? False lies or false truths or what? Alternative facts. This is an alternative fact, okay? No, it doesn't work like that. Sorry. That's 7. 5 does not equal 7. So what you do down here, this is fun, right? You're like, I don't think so. Remember that? I told you it doesn't work. So you got to be careful. If you pick numbers and it's working and it's working and it's working, that doesn't mean that it's true, right? That's the whole point I was trying to make with verification. No amount of verification constitutes a proof because you can find infinitely many values that make something true, but that doesn't mean that it's true for all values, okay? Therefore, we can't call it an identity because there might just be that one needle in a haystack that if you find it, this proves it. That's called a counterexample, right? Much easier to find a needle, by the way, in a needle stack than in a haystack, yeah? Yeah. Okay. You're right. You're right. Yeah. Yeah. Finding a needle in a needle stack is like shooting fish in a barrel.
Not if you're looking for a specific needle.
Not if you're looking for a very particular needle. Right. That's right. Right. That'd be like trying to shoot a particular fish in the barrel. You're right. You're right. It's all relative. Okay. Here's another quote unquote identity. I'm claiming this is true for all angles x plus y in the whole wide world. Now, y'all haven't had a lot of experience with this yet, but I'm thinking that when we get there in a couple of sections, you're going to see sine of x plus y, and you're going to be like, ooh, let's distribute sine of x plus sine of y, right? Okay. Right? You're going to try that, right? You're going to try that. Well, I'm telling you right now, when that time comes, don't try that. Do you remember when we had the natural log of x plus y? Was that equal to the natural log of x plus the natural log of y? No, it was not. Because in general, you cannot distribute a function inside its interior. You can distribute numbers into other sums, but you cannot distribute a function into itself in general, okay? In fact, the natural log of x plus y condensed down to the natural log of x times y, right? That was true. So it's going to work the same way with sine. So let's go ahead and pick a couple of angles. Now again, you don't want to pick 0 and 0. You want to pick a variety of angles. So let's choose some unit circle angles, shall we? Anyone for x? Throw one out there. 2 pi thirds. I'm sorry, I didn't hear that last part of it. And then y is pi halves. I like that. Okay, good. Sorry, Daro. No, it's not too bad. I started coughing and I didn't hear that second part. That was good. No. 2 pi thirds. Good. So let's plug it in. So we're going to get sine of 2 pi thirds plus pi halves. And over here, we're going to see if that's equal to sine of 2 pi thirds plus sine of pi halves. All right, so now we just work each side independently. Over here, your Aunt Sally is in the house. So we need to combine those. Now, 3 and 2 are co-prime in the denominator. See that? So you can do a little crisscross applesauce butterfly multiply thing. So you can go 2 pi times 2, that's 4 pi. Plus pi times 3 is 3 pi. 4 plus 3 is 7 pi. All over the product. 3 times 2 is 6. And now if you look at your watch, you'll notice that it is unit circle time, everybody. What time is it, boys and girls? 9:19. It's unit circle time. All right, what is sine of 7 pi 6? Negative 1/2. There you go. Darrell, that is redemption if I've ever seen it right there. What? He's just being funny. No, okay, I asked him for a unit circle angle, and he said 2, which is not a unit circle angle. But I think he meant 2 pi thirds. He was just waiting for a reaction from me, and he got it. But then I asked, what is sine of 7 pi 6? And before I even finished enunciating the word 6, Darrell said minus pi halves. All right. Or negative pi halves. I don't remember what he said. Okay. It's still unit circle time, everybody, even though it's now 9:20. Sine of 2 pi thirds is what? Square root of 3 halves. Man, you might want to move. It's getting hot over there. Darrow's on fire. I'm going to come keep you company, Daniela. Plus sine of pi halves. What's sine of pi halves? 1. All right. Now, 1 is the same as 2 halves. So That's the square root of 3 plus 2 over 2. Is negative 1/2 equal to that positive number? Not even, right? Not even. So you put your little contradiction there. I don't think so. That means not true. Okay? Now it may work for a few angles, right? Like 0 and 0, or 0 and pi halves. But if it doesn't work for all of them, doesn't work for any of them, we say it's not an identity. You cannot do that. All right? So you might want to just start by picking some variety of angles instead of, zeros. All right, so here's the other one that I already talked about. Do you remember Papa Pid? Yeah, it was cosine squared plus sine squared equals 1. And I told you that they had to be squared. You were going to get to a point in your trig proofs where you're going to see cosine plus sine, just like we have down there on the bottom left. And you're going to want to call it 1. You're going to want to replace it with 1. But you cannot, okay? Because if that were true, look, if I were able to take the square root of both sides, that would give me the square root of the first plus the square root of the second equals the square root of 1. Can I just take the square root of each term? No, we just disproved that over here, didn't we? It's the exact same thing that we showed does not work, okay? So let's go ahead and pick a few angles. What do you want to choose here? Now, this is the same angle x, so we're only picking one angle from the unit circle. 3 pi halves? Okay. Sometimes you could be it's a little bit dangerous to choose like quadrantal angles, but we'll see. We'll see. If you get it to be true and you suspect that it's not, just choose a different one the second time around. Cosine of 3 pi halves, I think we're going to be okay here. Plus sine of 3 pi halves. Does that equal 1? Well, cosine of 3 pi halves is 0. Sine of 3 pi halves is negative 1. Does negative 1 equal 1? I don't think so. Now, if you would have chosen 1 pi halves, you would have got 1 equals 1. If you would have chosen 0, you would have gotten 1 equals 1. So 3 pi halves was a good choice. Oh, gosh. Yeah, you're right. How many days into the AP Calculus exam? That's on the second Tuesday of AP exam. So if you back it up 9 days from what I'm about to put up there, that's when AP exams start. So again, you go to, it's 32. Yeah, 32 days. 32 days. So 25 days for y'all until AP exams start. 25 days until AP exams start. Thank you. What? Yeah, what time do we get? Are we on a special? Oh, there's no belts today. So we're fine for now. Yeah, thank you. Okay, I think we can work a little bit more of example 6 and then we'll shut her down, right? Shut her down. National Pet Day. You don't? The angle? We didn't want her anyway. Oh, is that why you moved? Oh, okay. Okay. You played along. That was nice. Yeah. All right. So we're going to now get into a taste, a little nibble of what proofs are going to entail. All right. It's like sticking your toe in the water before you cannonball. You stick your toe in the water, you lick your toe, and you taste the water before you jump in. No. Oh, Lauren just was like, no, I don't think so. Yeah. See, I don't know how to do things. I take adages and I okay, let's test the water, right? Get your toe wet. There's that so suck your toe all the way to Mexico. You remember that? Okay, I grew up in a strange place. And I'm still living in a strange place. Well, I came here in 5th grade. So my elementary years were in the Rio Grande Valley, 7 miles from the Mexican border. Yeah, I know. I know. I was called names. Um, yeah, yeah. We can get into that story later on. Okay. Simplify the following trig expressions to a power of a single trig function. So that's going to be like a trig function to the nth power of theta. So like sine squared of theta, tangent cubed of theta, something like that. So it's not quite a proof, but we have a vague target. Okay? We're starting with something, and we want to end up with some power of a trig function. When we do proofs, we're actually going to have a target on the other side. Okay, so here we go. Sine cubed of x plus sine of x cosine squared of x. How do we simplify? Well, I already told you we're working with expressions, so we can add a clever form of 0. We can multiply by a clever form of 1. We can expand things out. We can factor things out. We can combine like terms. We can divide out common factors. And we can make replacements of something with what it is equivalent to, namely identities. Those are the rules. So does anybody have any idea of possibly what we could do first? The first step is the hardest, right? The journey of 1,000 miles begins with the first step. Well, if you try to look for some algebra to do, we have two terms, right? Notice that, two terms. And do we have any common factors in the two terms? There is a sine of x factor that's common in both, right? So let's see. Let's factor it out. Sine of x, parentheses. If I take a sine of x out of a sine cubed, what does that leave me? Sine squared of x. Plus, if I take a sine of x out of a sine of x, I'm left with a 1. So that just leaves me with cosine squared of x. So that was a little bit of algebra. There was some obvious algebra to do. And by obvious, I use that in quotations. Like when the doctor said my brain scan came back normal. There is obvious math to do. So we factor out the sine of x. It's only obvious if you see it. Okay, now we kind of like look at it and see like, now what else? Is there any more algebra we could do? Or is there any trig substitutions that could take place? One trig substitution that could take place. Very good. Which one is it? One. Okay. Here's where if you don't know your identities, you're going to have someone standing in front of you going, hey, look at me, look at me, look at me. And he's going to be hitting you like, look at me. And you're like, stop it, I'm trying to do this. And guess who's slapping you in the face? Papa Pig, look at me, stop it. What? What is sine squared? Just keep going, just keep going. Pretend like it's normal. What is sine squared plus cosine squared? It's 1. It is 1. Look at that. That is handy. That is handy. That is like Flex Seal tape, baby. That is very handy. Peppa Pig. Yeah. Now, what is sine of x times 1? Sine of x. We got it down to a single power of a single trig function. It's sine of x to the first. And now my head hurts even worse. But you got the point. If you didn't have that memorized, you would be sitting there, just sitting there, right? You're just sitting there, right? Hurry up and wait. Right? You have no idea what to do because you didn't memorize. It's like playing chess and you have no idea what the rules are, right? You're like, can we just go back to the boxing? All right. Let's see if we can do one more, and then we will. Oh, let's stay with this one. Is that the only way to do it? No. How many roads lead from here to San Antonio? Many. One. Yeah. All roads lead to Texas, but there are many roads that from here to San Antonio. So there's other ways to do it. What? That's just an ethnocentric, proud Texas philosophy. Yeah. Like, I wasn't born in Texas, but I got here as soon as I could. David Crockett. All right, here's another thing we could do. If you didn't want to factor out, quote unquote, the obvious factor of sine of x, you could have said, okay, that's sine cubed of x plus sine of x, and then parentheses, cosine squared. By using Papa Pid, and here's where I told you could use these in other fashions. Cosine squared plus sine squared equals 1. So what would cosine squared equal? 1 minus sine squared. That's also an identity. Let's make that substitution. That's 1 minus sine squared. All right? And notice I have parentheses there. Muy importante, as we used to say down in the valley. Because it's true. We need parentheses there because we're replacing a single factor with a factor that's two terms. Okay? Now we did the identity replacement first. Now there is some, quote, obvious math to do. We're going to expand instead of factor. Some people think distributing is easier than factoring, and that's kind of a fair assessment. So let's see what happens. Sine cubed of x plus sine of x times 1 is sine of x. Minus, what's sine times sine squared? Sine cubed. Oh, hey! Epa, epa! What happens? ¿Qué tienes aquí? Yeah, nada. Ganz nicht. We get sine of x. That's what's the German, sorry. I know about a half of 3 languages.
An entire half.
So it's like 1.5, I guess, when you add them up. Which way is correct? Both. Very good. Very good. So the one on the left was algebra first and then trig substitution. The one on the right was trig substitution and then algebra. So as long as you have that fearless mentality that I'm going to do something, the journey of 1,000 steps starts with the first step, and I'm going to take one step. Just do something, right? You don't want to just sit there and be plagued with indecision. Okay, we're going to stop right there, I guess, for today, and we're going to go sign the banner.